This video is on Finance in Excel Part 2 from your lab book, and we're going to be looking at further applications of the FV, that future value function in Excel. And this section is particularly useful for Section 4C. Your book has some crazy long formulas. Please do not try to use those. You will almost guaranteed make a calculation mistake. It's much easier to use Excel for this section. So we're going to use the same FV function that we looked at in the previous video. I'm going to set up the same table, and again, I'm going to set up the table by looking at the inputs of the FV function. So it's APR, then N, Y, PMT, P, and then my function is FV. That's the future value. It tells me how much money I'll have in my savings account. And it's equals FV, open parenthesis, APR divided by N, comma, N times Y, comma, negative PMT, comma, negative P. And again, we will give you the formula that's in bold in your lab book on the test. You do not have to memorize it, but you do need to know how to set up this table. So previously, we talked about how APR represents the monthly interest rate, N is the number of times per year you're paid interest, Y is the number of years, and P is the principal. That's how much money you initially put into the bank account. Well, now we're also going to use PMT, which is the monthly payment. And think of this as a payment to yourself. It represents when you add money on a regular basis to your bank account. So looking at an example, it says Jim deposits $75 each month. So that's our PMT. Into an account with an APR of 1.45% compounded daily. And it says determine the balance in 10 years. So if you look in your lab book, there's a note. It says, when the payment time and compounding time units do not match, always use the payment time. This will give us a good estimate, but it might be off by a few cents or a few dollars. So we want to use the payment time, which is monthly, so our N is going to be 12. Technically, since it's being compounded daily, N should be 365, but that note tells us to overwrite it. In order to make this function work, our N and our payment schedule must be the same. So we're going to use 12 since we're making monthly deposits. And then it doesn't say that Jim has any extra money, so our initial principal is 0. So that tells us if Jim puts this amount of money into his bank account every month, at the end of 10 years, he'll have $9,678.93. So just for fun, let's look at how much money Jim put in. So he put in $75 each month, 12 months a year for 10 years. So he put in $9,000. So that was his total deposited money. So his total interest would be the amount he ended up with minus the amount he deposited. So he made almost $700. He made $678.93 in interest. That's pretty good. All right, let's go to the next page and do some more. So I'm going to drag my formula just over for a bit so I don't have to retype it in. So again, for Jim, the question asks how much money will he have? That was at $9,000. So the next page, it says Andrea wants to know how much money she will have in 5 years if she deposits her $500 tax refund in an account. So that's an initial principal. That's $500 that pays 2.2% compounded monthly. So that's 12 times a year. And then she adds $15 each month. So now we're going to do an additional $15 each month. And we'll see that at the end of the 5 years, she'll have $1,508.53. So Andrea, she deposited $15 a month, so 15 times 12, for 5 years, and then she also put in $500 initially. So her total deposit amount was $1,400, so her interest that she earned was a little over $100. So the total amount of money that you put in is whatever your initial principal is plus all of your monthly payments, and you can subtract that from your total future value to see the amount of interest you accrued from the bank. So a little bit further down the page, it says Andrea changes her mind and instead that she wants to know how long she must continue the savings plan to reach a future value of $2,000. So the saving plan's the same, 2.2% interest, 12 months a year. She's putting $15 a month in with that initial deposit of $500, but the question says, how long will it take? That's a goal seek. We're trying to figure out the number of years, and we want her to get up to $2,000. So I'm going to click on my formula, go to Data, What If Analysis, Goal Seek. we want to be to $2,000, and the question saying how long is that going to take? Our changing cell is the years. So it's going to take 7.25 years for her to get $2,000 in the account. And again, if we wanted to figure out how much she deposited, she did 500 times plus $15 a month for 12 months a year times 7.25 years. And so she made almost $200 in interest. That's decent. Yeah, more money is better than less money. And then at the bottom of the page, it says, similarly, Andrea wants to have a balance of $2,500 in only 7 years. We want to use goal seek to solve for the APR. So it says solve for the APR. That means we need to figure out what our APR is. For the monthly required, so monthly is 12, for the same amount in 7 years. So we're assuming that she's still putting $15 in a month with the $500 initial payment. So again, it's saying how much will the APR need to be to get her to, what was it, $2,500 in 7 years? So we need to goal seek it to $2,500 by changing our APR. I'm going to turn it into a percent with 2 decimals just to make it look pretty. So she needs 7.55% interest to get the $2,500 in 7 years. Alright, so on the next page, we have some questions about Mario. Just for practice, I'm going to set up my chart one more time. We have our APR in Y, PMT, P, and then our future value formula is equals FV parenthesis APR divided by N, comma, N times Y, comma, negative PMT, comma, negative P. And remember, those negative signs are the most commonly forgotten part. And let's see, we've got 4 parts, so I'm going to drag it over so we don't have to retype it in. Alright, so it says Mario is setting up a money market account with an APR of 3.75% compounded monthly. So this is for all of our problems. Let me just drag that over so we have it. Okay, so the first one, it says Mario starts making deposits of $100 per month for 5 years. So it doesn't say that he puts in any money initially. So Mario is going to have, at the end of 5 years, $6,588.08. Okay. So it says if Mario starts making deposits of $100 per month, I just confused myself. All right, so if Mario starts making deposits of $100 per month, so it's $100 per month, how long will it take him? So it's asking for years. How long will it take him to accumulate $6,000? So again, it's not saying that he's putting any money initially in, but he's saying how long will it take him to put in $100 a month so he gets $6,000 for his dream vacation. So we need to goal seek this to $6,000 by changing the time. And at this rate, it's going to take Mario 4.589, so about 4.6 years, to get $6,000 for his dream vacation. So that's a long time saving, $100 a month. Right, the next one, Mario has received a $1,200 bonus for working extremely hard. If he opens the money market account with his bonus, so now his initial principal is $1,200, and then deposits $100 into the account every month, what will the account's future value be in 10 years? So at the end of 10 years, wow, look at that. He'll have a lot of money, $16,277.48. And then the last part, it says if he deposits $700 today, and he wants to take his dream vacation in 3 years, how much will he need to deposit every month until then? So now we're trying to figure out what is his monthly deposit. So we need to goal seek it. Let's see, this is for his dream vacation. It told us in the second part that his dream vacation was $6,000. And this time we're going to do it by altering his monthly additions. And so Mario would need to put in $137 and about 14 cents a month to get his $6,000 dream vacation in 3 years.